Welcome to Maths with EJD. In this video, I'll be talking about the integral test. It's one of the tests for convergence. It's one of the tests for convergence. In the previous video, we had considered the n-term test for divergence. So now our focus turns to the integral test and the concept straight to it. The concepts of the integral test is something like this, that for a positive, okay, for a positive continuous and for a positive continuous and decreasing function, decreasing function, okay, Fn, which is equal to An, then if the integral from 1 to infinity, if the integral from 1 to infinity, okay, let me write that aside. So for a positive continuous and decreasing function Fn, f of n equals an. So if the integral from 1 to infinity of f of x dx converges, okay, if it converges, then we can say that the summation, that is the series, right? Series of an actually also converges. So that's a simple concept there. All right. Then it converges. On the other hand, if, okay, on the other hand, right, if the if the integral, if the integral diverges, if the integral diverges, then the series also diverges. The series diverges. So the integral determines whether it converges or it doesn't. Okay, that's basically the idea of the integral test. Can we take some examples to drive the point right home? So imagine that we need to test. So let's take example one. Example one. So test the series, test the series summation from n equals 1 to infinity of 1 over n squared. That's what we want to test. And right there, the solution is we want to do that for the integral test. So we need to evaluate. So we need to uh evaluate. Okay. Yeah, the first thing we want to do is consider, right? We want to consider f of x equals 1 over x squared because, from the rule, right, f of n is an, then we check f of x. So we see already here. Okay, let me even take it step by step. Consider that f of n that we have from here is 1 over n squared. That implies that f of x is actually 1 over x squared. Okay, that's 1 over x squared. So the next thing we want to do is to evaluate. So we now have to go and evaluate integral from 1 to infinity of f of x dx, which is integral from 1 to infinity of 1 over x squared dx. Okay, now how do we do this? Surely this is integral from 1 to infinity of x raised power minus 2 dx. So if you don't know how to integrate it, I broke it down from beginning to the end in the playlist on basic calculus. I think that was like the second or third playlist in this on this channel. So here now we have the integral from 1 to infinity of, now the idea of integration is, if you have integral of x dx, or let me put it this way. Yeah, if you have integral of x dx, right? If it's a polynomial, so you're just going to have the power of x here is 1. So you have 1 plus 1 divided by the new power divided by 1 plus 1, basically. And then that is like x squared over 2 plus c. That's not what is called an arbitrary constant. So in this case, to integrate this now, you just have x raised to power minus 2 plus 1 all over minus 2 plus 1. And that's from 1 to infinity. Okay. So that means that, of course, we're still talking about the integral from 1 to infinity of f of x dx. Of course, our that's 1 over x squared dx, right? So we go and say that this is actually x raised power minus 1 all over minus 1 from 1 to infinity. So this is, so we have to evaluate at those limits. So here we have, okay, that's more like having minus 1 times, minus 1 under there times 1 over x, which is x raised power minus 1 from 1 to infinity. So we can put the minus outside. So we have 1 over x from 1 to infinity. So we can evaluate with all of that. So we have minus. So put infinity, that's 1 over infinity, minus put 1, that's 1 over 1. All right. So what do we say? So this is minus. Interestingly, 1 over infinity, just like we saw in the previous video, is 0. 1 over 1 is 1. So what do we have? We have that this is 1 into minus 1, and this is equal to 1. So it means, of course, the integral from 1 to infinity of f of x dx is equal to 1. So, I mean, the answer is 1. How do we know that whether it converges or not? Convergence means that we have a particular value to what that the integral results to. Divergence means that probably the answer is infinity. It's undefined. So how do we conclude this situation? So to conclude that, right, we now say that um, since since the integral from 1 to infinity of 1 over x squared dx, okay, since the integral of 1 over x squared dx from 1 to infinity is equal to 1, and that means it's not undefined, right? Since it's equal to 1, then we say that this integral converges. This integral converges. And so series, the series we're given summation from n equals 1 to infinity of 1 over n squared, the series also converges. That is the implication of that. The series also converges. Okay. So let's take the second example. Example 2. Example 2. Okay. So example 2 now. So we want to check again. So we want to test summation from n equals 1 to infinity for 1 over n. So test if that series converges or diverges. Okay, using integral test. So following from the integral test, right? We already knew that from the other test, the uh nth term test of divergence, we already discovered it diverges. Is the integral test going to tell us the same thing? So again, what do we have? We have an to be 1 over n, right? Okay. So how did we approach it the other time? Yeah. Okay, we have f of n. Yeah, it's called f of n, not an. So consider that f of n here is equal to 1 over n. Okay, that simply implies that f of x is also going to be equal to 1 over x. Okay, so we now need to evaluate. So we need to evaluate the integral from 1 to infinity of f of x dx, and that is integral from 1 to infinity of 1 over x dx. Okay, so and that means that integral from 1 to infinity of 1 over x dx is simply okay, we cannot do what we did the other time with this, but so we just go straight and say that of course, from the our knowledge of integration, this is simply ln x. Okay, ln x. So we have ln x from 1 to infinity. So ln x from 1 to infinity. So obviously, ln of infinity minus ln 1. Ln of infinity is simply undefined. Ln 1 is 0, and everything is undefined. Okay, so now, so therefore, integral from 1 to infinity of 1 over x dx is infinity. Uh, so this integral diverges. The integral diverges. Okay, so how do we conclude? Now say since the integral, since the integral 1 to infinity of 1 over x dx diverges, okay, then the series, which is summation from n equals 1 to infinity of 1 over of 1 over n now, also diverges. And that is how that is. Okay, so that's all. Straight to the point. That's what the integral test is all about. So if you have an expression you want to integrate to see if you get infinity or you get a proper answer. Any other answer you get apart from infinity is good. All right. So it means that the integral converges to that particular number. So in the next video, I'll be talking about comparison test. So watch out for that. If you have not subscribed to the channel, you want to do that right away. All right. You want to subscribe right away and so hit the notification bell so you can always get alerted each time a new video is released. And you also want to comment to let me know how helpful these videos are for you. And if you want to solve a problem or teach a topic, all right, then you also want to like and share so that more people can have access to this great content. Till I come your way again, keep doing math right. Bye.